So good morning, students, once again, and welcome to the Q&A summer course. I think this is your first class for physics today, and we'll be starting with the first chapter, that is motion, in today's class. Okay, so yeah, we can make the class interactive, so you can ask your doubts if you have some. You can unmute yourself and you can ask the doubts when I ask you. Okay, and so let's start the session, students. So the first chapter today, which we are going to start in class 9th, is motion. So let us first understand the prerequisite of this. So if you see, the prerequisite of this chapter is you should know basic mathematics. You should know something about distance for this class, if I talk about, and you should also know the basics of speed. So all of this you have already done in your previous grades, in grade 7 and grade 6, where you have learned about distance and speed. So you should know all of this to understand today's lecture completely. Okay. Now, if you see the weightage of this, so for this chapter, there is 8 to 10 marks weightage in exam. So you can expect in annual exam, if I talk about if the whole syllabus is coming, so out of 80, you can expect 8 to 10 marks coming from this chapter. So in whatever exam, let's say if it is, let's say 60 marks exam, so 10% of that total marks you can expect from this particular chapter. Okay, so now let's talk about the outline of this chapter. So what are we going to study today? So we are going to study motion and rest. So what is rest? What is motion? We are going to study types of motion, distance and displacement, and few illustrations and examples to understand these concepts well. Now, let us start with the basics. So what do you observe here in this? So you can observe that a cyclist is riding the bicycle. There are a few birds which are flying. There is a car which is moving. So in all of this, what you can observe is these things are moving. There is motion involved in each of these objects, right? So now, what do we observe here? So we observe that the objects are in motion, right? Now, why do we say these objects are in motion? So how do you get to know that these objects are in motion? Anyone? Anyone who wants to answer here? How do you observe these objects to be moving? Anyone who wants to answer? You can unmute and answer as well. Or you can type it, whatever is convenient for you. Okay. So we say that object is moving because all of these objects are changing its position with respect to a fixed point, with respect to the surrounding. Okay. So in all of this, there is a change of position happening with respect to the surrounding. So let's learn in this chapter, how do we say that objects are moving? So what is meant by motion? So let us consider an example of an observer observing the car. So let's say there is an observer and there is a car. So he observes that the car is moving with respect to some, fixed position. So let's say if I talk about this position, there is a way direction kind of thing, which with respect to which the car is moving. So position of the car is changing with respect to its surrounding, with respect to road or any stationary object. With respect to any stationary object, if the position of the car is changing, we say that the car is moving. Okay. Now let's go ahead, student. So the car is in motion. We say that the car is in motion because this car is changing its position with respect to the surrounding. So a body is said to be in motion. So from this we get a basic definition of motion. What does it say is that a body is said to be in motion when it changes its position with respect to its surrounding. So a body is said to be in motion. I'll repeat it again. You can write it in your notebook. So everyone, you should have a notebook and pen ready with you when you come for the class, so that you are able to write the notes, which you can use it when you join back in school. So you will have a notes ready and your performance will improve when you revise these notes before your exams. So a body is said to be in motion when it changes its position with respect to its surrounding. Okay, is it clear to everyone? Yes, Sanjeev, with respect to the, so body is said to be in motion when its position changes with respect to time, obviously, and with respect to its surrounding. So you can include time here as well. Okay. Now here also, if you see in this clock, you can see that the seconds hand is moving with respect to a fixed position. So that fixed position is called the reference point. At times it is also called origin. So here in this, you can see that this was the fixed position from where this seconds hand started moving, and this shows that the seconds hand is moving because it is changing its position with respect to a fixed reference point. Is it clear? So, you can always raise give me a thumbs up when you have understood the concept, or you can write in the chat box once you have understood the concept. You can also unmute and you can answer that whether you have understood the concept or not. So the position of the hand of the clock changes continuously. So we say that this hand of the clock is moving because its position changes continuously with respect to a fixed reference point. So the hands of the clock are in motion. So when the position of the hands of the clock changes with respect to a fixed position, then we say that it is in motion. Now next, in this figure, you can see that water is flowing in the river, and so here in the river, the position of the water changes continuously. And again, we can say that the water is in motion. Now, third case, you can see the earth is revolving around the sun. So due to revolution, the position of the earth with respect to sun changes continuously. And again, we say that the earth is in motion. Clear? Let's go ahead. So now that we have defined what is motion, now let us understand what is rest. So when does a body when do we say that a body is at rest? So a body is said to be at rest again if its position does not change with respect to a fixed, with respect to the surrounding or a fixed reference point, or with respect to time. So when you are talking in terms of time. So if the position of the object does not change with respect to the surrounding, we say that the body is at rest. Is it clear, students? Is it clear? Everyone has understood the concept of rest as well? Okay, thank you. So let us consider an example of an observer observing the car stopping at a signal. So let's say a car has come to the signal and it has stopped. Kavin, the object. So your question is, can an object move without respecting its surrounding? So with respect to surrounding, an object, see, when the object is moving, it will always be with respect to the surrounding or with respect to the fixed reference point. We'll come to this concept about relative motion as well in a while, and then we'll understand the other aspect of this as well. Okay. So the position of the car is not changing with respect to its surrounding, then we say that the car is at rest. So when the position does not change with respect to the surrounding or with respect to a fixed point or with respect to time, we say that the body is at rest. So a body is said to be at rest when it does not change its position with respect to the surrounding. So this is the definition for a body to be at rest. Okay. Now let's go ahead. So now this is what we were discussing, Kavin, a while ago. So what is when we say that motion is relative? So what does relative motion mean? So motion is relative means a body can be can be in motion with respect to one observer, and with respect to other observer, the same body can be at rest. I'll give you an example. So for example, when for example, I'm going in a train. So when I'm inside the train, so the person who is sitting in front of me in the train, he would be at rest with respect to me. So when the observer is inside the train, the other person who is sitting in the train, he may be at rest with respect to that observer. But the same person who is inside the train, right, when observed from the platform or outside the train, let's say on the road which is there, which is parallel to the railroad. So there, that observer, when he is observing from outside the train, he'll observe that person who is sitting inside the train to be moving when the train is moving. So the same object means the person sitting inside the train, when observed from inside the train, he will be at rest. But when he is observed from outside the train, he will be in motion. So there is a difference here. So motion, that's why we say that motion is relative, right? It is not an absolute quantity. We always talk about motion with respect to some observer. That observer can be inside the train or outside the train. When the observer is inside the train, he will observe that other object or other person who is sitting inside the train to be at rest. And when he is outside the train, he'll observe the same passenger who is sitting inside the train to be in motion. So again, so motion is relative and it depends on the observer. So a body can be moving for an observer and at that same time at rest for another observer, right? So this is what it means when I say motion is relative. So now there is this question, right? So you have to answer, students. So when in motion, the body changes its dash with respect to the surrounding. So when the body is in motion, what changes with respect to the surrounding? Yes, position. Sanjeev, correct. Yes, it is position. The position will change with respect to its surrounding. Good. Now let's come to the second question. So the second question is, an object may appear to be moving for one person and dash for another person. Which option would be here? An object may appear to be moving for one person and dash for another person. Yes, correct. So it is stationary for another person. So an object may appear to be moving for one person and stationary for another person. So here the option A is the correct option. Okay. So an object may appear to be moving for one person and stationary for another person. So the answer option here is A, stationary. Okay. Now let's again recollect what we have studied till now. So a body, so first of all, let's understand the definition of motion and you can write it down as well. So a body is said to be in motion when its position changes continuously with respect to a stationary object taken as a reference point. So this stationary object sometimes is also called origin. So when a body changes its position with respect to a stationary object which is called the reference point, and that reference point at times is also known as origin, such a body is said to be in motion. So an object may appear to be moving for one person and stationary for some other. So this is what we mean when we say that motion is relative. Is it clear? Is it clear to everyone? This concept is clear to everyone, students? Yeah. Yeah. Do you have a doubt? Someone raising hands. Sanjeev, do you have a doubt? Okay. So let's go ahead, students. Now, what are physical quantities? Can anyone tell me what are physical quantities? What are physical quantities, student? Anyone who wants to answer?
The one which requires only the magnitude to be measured.
Yeah, so any quantity, any quantity in physics basically, which can be measured, right, is called physical quantity. So all quantities which can be measured are said to be physical quantities. So anything that can be measured is called a physical quantity. So can distance be measured? We can measure distance, right? So since distance can be measured, distance is a physical quantity. Okay. So similarly, we know that time can also be measured, and we say that time is also a physical quantity, right? Now there are two types of physical quantities. One is scalars and other is vectors, right? What are scalar quantities, students? What are scalar quantities? Okay. Okay, so scalar quantities are those quantities which has only magnitude. Okay, so there are two kind of physical quantities, one which has only magnitude and other which has magnitude as well as direction. So those physical quantities which has only magnitude are called scalar quantities, and those physical quantities which have magnitude as well as direction are called vector quantities. Okay, so for example, distance is a scalar quantity and displacement is a vector quantity. Similarly, so when we say that a body is moving 3 kilometer, right? So that means we are talking about the distance. And when we say that when a body is moving 3 kilometer towards north, so when we also specify the direction, it becomes a vector quantity. So 3 kilometer towards north is displacement, which is a vector quantity. And when I say only 3 kilometer, it is distance, which is a scalar quantity. Similarly, when I say a body is moving with a speed of 10 meter per second, so because here we are only mentioning the speed, right? So it is a scalar quantity. We are only mentioning the magnitude here. So 10 meter per second is the magnitude. And when you only mention magnitude, it is a scalar quantity. So speed is a scalar quantity. And when I say 10 meter per second towards north, so here we are also mentioning the direction. So what is the speed? 10 meter per second. And what is the direction? It is towards north. So here magnitude and direction both is mentioned, and that's why it is a vector quantity. So physical quantities are of two types. One is scalar quantity and other is vector quantity. Okay. So what are scalar quantities? So physical quantities which can be completely described by their magnitude alone are called scalar quantities. So those quantities which can be completely described by only its magnitude, we say that these quantities are scalar quantities. Okay. Example of scalar quantity is time, mass, and as I also said, there are two more examples of scalar quantity. You have distance. This is also a scalar quantity. Speed again is a scalar quantity. So these are two more examples of scalar quantity. Now let's talk about vector quantities. So here if you see, to measure the time, direction is not required. So it is a scalar quantity. You only say that it is 10 seconds now, or when you measure time, you can measure it in minutes or hours, or year, or some other unit, but you will never mention the direction there, right? So time is a scalar quantity. Now again, mass, when I mention the mass of some object, so for example, mass of this piece is, let's say, 200 grams, then we say that the mass of this object is 200 gram. And here again, you are only mentioning the magnitude and not the direction. So mass is a scalar quantity. Now, let's talk about vector quantity. So a physical quantity which possess magnitude as well as direction. So those physical quantities which has magnitude as well as direction are called vector quantities. Example of vector quantities are force. So force is another example of vector quantity. When I say that I am applying a force 3 Newton towards right, So here we are mentioning the direction, right? Or 2 Newton towards left. So here again the direction is being mentioned. So magnitude as well as direction both are mentioned, and that's why it is a vector quantity. Similarly, displacement is another example. As I said, velocity is again a vector quantity. Acceleration is again a vector quantity. So all of these physical quantities which are which we are going to study in this chapter, velocity, acceleration, and all of this. Is it clear, student? Has everyone understood the concept? Okay, good. So to measure force, both magnitude and directions are required when we say that we are pushing some object, pushing in what direction. Similarly, when I say I am pulling the object, pulling in which direction. So all of this, when you are mentioning force, you will also have to mention along with the magnitude, the direction of that force as well. Now units are a system of measurement. So when you measure a quantity, so you always have a unit against which you are measuring something. If you are measuring length, you will have a unit to that. So that is a standard unit which generally people use standard units. For example, for length we use meter as standard unit. Similarly, for time we use seconds as standard unit. For different physical quantities, there are different units which are there, right? Now, for length, we can have different units, meter, centimeter, kilometer, all of these units can be used. So one of those units has been made a standard, and that is called standard unit and international standard, or system day international units. So there are two types of units which we come across in our daily life. One is your MKS system and other is CGS system. Can someone tell me what is MKS system and what is CGS system? What is MKS system? Anyone? Okay. So, Kavin, I'll tell you. So MKS system is basically meter, kilogram, and seconds. So here, meter is the unit for length, kilogram is the unit for mass, and second is the unit for time. Okay. So these are three basic physical quantities: length, mass, and time, for which we are having standard units here in MKS. So in MKS system, uh, for meter is for length, kilogram is for mass, and second is for time. These are standard units. And for CGS, it is centimeter, gram, and second. So for length here, the unit is centimeter, and for mass here the unit is gram, and for time it is seconds. Is it clear? Metric system is something else. Metric system means, where when you have to change one unit from the other, you do it by either multiplying it by the powers of 10 or by dividing it by powers of 10. So such units are called metric system. Okay. Yes, both sides. In MKS also for time it is second, and for CGS also for time it is second. Okay. Let's go ahead, student. So MKS system was further, there were further, there are 7 fundamental quantities, right? So three we have already seen: mass, length, and time. So there are other fundamental quantities as well. So for example, we have for brightness, we have luminous intensity, right? And for temperature, we have, Kelvin. So these are different fundamental physical quantities which we use to define various physical quantities. So now, out of those, for mass, length, and time, there were 3 units which was standardized, which was made as standard units, and they were taken from MKS system only. So MKS system further refined into SI system, which is called System International Unit or Standard International Unit. Is it clear, students? Is everything clear to you? Do you want me to further elaborate this, or you have understood the concept? Okay. Now let's come to the concept physical quantity, which is of interest. So first physical quantity which we are going to study in this chapter, motion, is distance. So let's start with the definition of distance. What is distance? The distance traveled by a body is the actual length of path covered by a moving body, irrespective of the direction in which the body travels. So distance is the actual length of the path. For example, there is this object, the body is, let's say, starting from A and it has to reach B. And let's say the path which it has taken to go from A to B is this. So this is the path which the body is taking to move from A to B. So this path, the length of this path, how do you measure the length of this path? So I'll tell you. What we generally do is, if we have to measure the length of this path, so what we'll do is that we'll have a thread. For example, if I have a thread, so I'll put the thread along the path. So if I put the thread along the path here from A to B, right? So I'm sorry. Uh, yeah. So if we Yeah. So if we, from here, from A to B, if we put the thread here and along the path, and then when we take the thread and measure the length of that thread, that will give me the length of the path length, and that path length is actually the distance traveled. Is it clear, student, what is distance traveled? So we actually measure the length of the path along the curve, right? So that is the distance traveled. Now distance is a scalar quantity because here there is no direction. We only mention the magnitude. Magnitude would be the length of that path. Okay. And distance traveled has only magnitude. That's why it is a scalar quantity. Okay. So here this length of the path would give you the distance. Okay. Now it is a scalar quantity. Now let's come to displacement. So again, we take the same example. Let's say the body is at A and it has to go to B. So let's say this is the path it is taking to go from A to B, and this is the length of the path, right? Now, when I say this is, if the path length is distance, now the shortest distance between the initial and final position. So how will you find the shortest distance? You will join A to B, right? So this is the shortest distance. So this shortest distance from A to B is called the displacement. So when a body moves from one position to another, so the start position is A and it is moving to the end position B, the shortest distance between the initial position and final position of the body along with the direction is known as displacement. Here direction is important, right? So this will always be from A to B. A to B is one direction and B to A is some other direction. So here the direction is important. It is starting from A and going to B. Shortest distance along that. That will be displacement. And because we also have to mention the direction here, displacement is a vector quantity because it has magnitude as well as direction. Is it clear to everyone? Students, is it clear? Okay. Now, let's further understand the difference between distance and displacement. So, distance, we know that is a scalar quantity because it has magnitude only, right? And it has no specified direction. Displacement is a vector quantity. So distance is a scalar quantity. Displacement is a vector quantity. Vector quantity because it has magnitude as well as direction. So let's take one example. So we have initially also discussed about this. So if a car travels a distance of 50 kilometer, then the expression 50 kilometer is the distance traveled because you are not mentioning the direction here. Now, if the car is traveling in a straight line in the east direction, so if the car is traveling in the straight line in the east direction, so here direction is mentioned. So the expression 50 kilometer towards east you are specifying the direction as well. So it becomes the displacement of the car. So when you are only mentioning 50 kilometer, that means it is the distance. When you are mentioning 50 kilometer towards east, that means you are also specifying the direction and it becomes displacement and hence a vector quantity. Clear, students? Have you understood the concept of distance and displacement? Okay. Now, another concept, the distance traveled by a body cannot be zero, but the final displacement of a moving body can be zero. Can anyone tell me an example of how this can be possible? So distance, let's say a body is moving from one position to other. We say that there will be some distance which the body would have covered, right? Very good, Sanjeev. So if starting and ending point is same, then we say that it is the displacement is zero. So for example, let's say a body starts from A, right? So it goes to point B and then again comes from back from B to A. So the body has gone from A to B and then came back from B to A. So here what is happening is that body starts from the same position and you know returns back to the same position. So initial and final position remains the same. So when initial and final position remains the same, even if the body has covered some distance, the displacement will be zero. Because displacement, what is the definition of displacement? The displacement is the shortest distance between initial and final position. When initial and final position is same, what is the shortest distance? The shortest distance is zero, right? So in that case, the displacement will become zero. So the distance traveled by a moving body, whenever a body is moving, distance cannot be zero. But final displacement of a moving body can be zero when initial and final position when initial and final position is same, we say that the body has a displacement of zero. Okay. So if we take a round trip and reach back at the starting point, then though we have traveled some distance, our final displacement will be zero. So whenever you take a round trip, okay. So whenever you take a round trip, you reach back at the starting point and then in that case, final displacement is zero. So this is because the straight line distance between initial and final positions will be zero. Okay. Now let's come to this question. So an ant travels a distance of 8 centimeter from P to Q and then moves a distance of 6 centimeter at right angles to PQ. Find the resultant displacement. You can try it once. So let's see the question. What does the question says? An ant travels a distance of 8 centimeter from P to Q. Let's say this point is P and ant travels a distance from P to Q and this distance is, let's say, 8 centimeter. Now then moves a distance of 6 centimeter at right angles to PQ, right? So let's say it has moved a distance and it has reached R and the distance covered is 6 centimeter at right angles to PQ, right? Sanjeev, you are correct. The answer is 10 centimeter. Okay. Okay. So now when we say the resultant displacement, you will have to find the shortest distance between initial and final position. So this is P is the initial position, R is the final position. This is the shortest distance between initial and final position. So this is a right angle triangle. If you have to find this distance PR, so by Pythagoras theorem, this is equal to root under PQ square plus QR square, right? Perpendicular square plus base square will give you hypotenuse, the value of hypotenuse. So PQ is 8. So 8 square plus 6 square root under will give you PR. So PR is equal to root under 64 plus 36. So what is 64 plus 36? This is equal to root 100, which is equal to 10 centimeter. Is it clear, students? Everyone has understood this? Okay, good. So let's come to the next one. Now, distance and displacement. Okay. So what does distance and displacement, the difference means, let's see this, these slides and you will understand it better. So let's say from one part of the stadium, one portion of the stadium, let's say there is an athlete who starts running and she has to reach this other part, diametrically opposite point B. So B is the final point, A is the starting point, for example, and there is an athlete who starts running the race and reaches from A to B, right? So the distance traveled will be half of the circumference. Clear? So the distance traveled, let's say, is 250 meter here. Okay. The distance traveled here is 250 meter from here to here. Okay. So this is equal to 250 meter. Now the athlete is covering a path length of 250 meter between A and B. The actual path run by the athlete is called the distance. Now, if you have to calculate the displacement, what will be the displacement? The shortest path between A and B. This is the shortest path. So shortest path between A and B is, let's say, 160 meter. Okay. So this is 160 meter and this distance was 250 meter, right? So here 160 meter becomes the displacement and distance is 250 meter. Is it clear? Now let's say if this athlete has gone completed one complete round of that field, so the total distance covered, because half of the circumference was 250 meter, so total circumference will become 500 meter. So this is the total distance traveled here. So distance traveled is 500 meter in this case. Now if you find the displacement, because the initial and final position is same, the displacement here will be equal to 0. So from A to B, if we say the distance is 250 meter and displacement was 160 meter, from A to A means starting point and initial position and final position, if it remains same, in that case distance becomes 500 meter and displacement becomes 0. Is it clear, student? Everyone has understood the concept? Okay. So students, you know, so we will do further examples in the next class. So today what we are going to do is that, so we'll conclude the class here. So what did we study today? We studied about rest, body in motion, distance and displacement. And in tomorrow's class, what we are going to do is we are going to do few examples more on distance and displacement. We'll start the class with that. Whenever you have your physics class, we'll do distance and displacement questions. And then we'll also do uniform and non-uniform motion. We'll talk about speed. Okay. So all of this we are going to cover in the next class. Okay. Now, average speed is also what we are going to cover in the next class. Velocity is something which we are going to cover in the next class, and average velocity. So these are the portions which we'll cover in the next class. So thank you, students. Thanks for joining in. And, as I said in the orientation session also, what is required is discipline in terms of, joining the classes regularly. Don't miss the classes. You will get benefited out of these classes. And, if you miss a class in between, there will be no link between the previous class and the next class, and then you will not be able to understand the concepts well. So today was most of introductory class kind of thing. We'll delve deeper into the concepts. We'll do questions, numericals based on these concepts. So physics in class 9th is all about understanding numericals, solving questions, applying the concepts which you have learned. So you are going to enjoy it a lot. So keep on learning, keep on attending the class regularly. Thank you, students. Thanks for joining in. Bye and take care.